John's from ERI, is one of the several manufacturers, and thank you for sponsoring. And gonna take a look at how different changes and adjustments and sizes will affect different devices, and we want to think about how can we get more consumers. So, yeah.
Thank you, Mark. That's my presentation, SFS. Let's see, how do I? Oh, okay. So this presentation is meant to be just a real high-level overview of some of the benefits to the consumers of NextGen TV, and really just wanted to cover some of the different techniques that we can use to benefit consumers. So first is, it's got a much more robust signal. It has less breakups, better in-building penetration, fewer dropouts, much improved urban canyon reception, and really kind of the target is to go below grade in some cases and deep indoors. So for ATSC1, our target was to deliver signal here to the rooftop or an external antenna. Now our planning needs to change to be much more focused on all levels of the house. Hello? Come back.
Oh, there.
No? There we go. Okay. I think I hit the wrong screen here. As I was saying, the goal is to deliver the signal to all levels of the house and even below grade. Because the devices that we're going to use are going to change. Not just be the wall-mounted TV anymore, but handheld devices and tablets. The challenge is the dense urban environment, where we need to be able to deliver signal to all levels of buildings in an environment like this with lots of multipath. We need to get signal deep indoors. We also have a mobile market that we're trying to target. So we need to be able to deliver signals to automobiles, vehicles of all kinds. To take advantage of NextGen TV features, we will need to ensure the reception throughout the service area. So, quick review. More robust delivery that comes inherent with the standard, more flexibility in the types of services that we offer, more platforms, from televisions and TVs mounted on the walls to tablets, user devices. So I can hear your bosses and Captain Kirk calling up to Scotty, we need more signal. So how do we get more signal? Well, first is just the inherent superior reception that comes with the receive characteristics of OFDM. I propose that we're going to need to use lower gain antennas on the receive and the transmit side. We're going to have to increase the vertical polarization in markets and use higher transmitter powers to compensate for vertical polarization. And then, as Mark was teeing up for me, we're going to use secondary emitter sites, create an SFN. These are some of the techniques that we're going to use to provide much denser signal throughout the desired coverage area. There we go. So one of the keys, in my view, is we're going to have to design for the use cases. Likely this is going to require having very high null fill to cover close into the tower and secondary emitter sites. Main antennas are going to provide our service throughout the majority of our coverage area, but we're going to need to fill in using secondary emitters. SFN and secondary emitters are going to provide a much denser signal throughout the entire coverage area. And we're going to have to take a lot of care in designing these sites, making sure that we're accounting for the higher power level of ATSC3 and adjacent market, self-interference, and a host of other considerations. Benefits to the consumer are, first, this incredible signal that we're going to have in our homes, picture and sound of ultra high definition. That's the first. The second is they're going to be able to use and watch NextGen TV in a wide range of different areas. You're going to use NextGen TV enabled mobile phones and tablets. Home gateways are going to deliver signal in our homes as well to Wi-Fi enabled devices like we just heard about. And the automotive industry. I'm hoping someone out there is talking to Mr. Musk and Mr. Hackett and the other CEOs about getting devices, receivers in the automotive industry. I think that'll be big. So the build out of NextGen TV is going to first require turning on the main signal. There's a host of things involved with getting those agreements technical and business, all that, turning on the lighthouse and getting the first signal on air. And then we're going to have to add in the SFN sites. Varying antenna heights will be critical as we build out the SFN networks. SFN networks are going to require us to have a really close look at how we design these systems using filters, combiners, and transmission line. We're going to have to size everything for much higher power level of ATSC3. So quick shameless plug, the super panel antenna from ERI is ideal for secondary emitter sites. It's a very versatile antenna, and we think it's ideal for SFN networks. A couple projects that ERI has been involved in for NextGen TV, WRAL, first ATSC3 site on air in June of 16. Pearl Phoenix, the Shaw Butte site, and Michigan State ATSC3. So what I'd like to thank Peter and Fred for the opportunity today. I'm going to bring up Jeff Andrew of Osborn Engineering. He's going to go much more detail into SFNs and some of the work that they've been doing on a couple markets, and then we'll take questions after that.
Okay, well, hold your question. We'll take it at the end.
Okay.
Jeff's.
Thank you.
Yeah.
Okay, this is right here.
Yeah, well, I think we need to get out of your program.
Okay.
And get into yours. Jeff has a lot of time here in the Washington, D.C. market, Tegna and Fox, and now with Osborn Engineering. There you go. Okay.
Thanks, Fred. Thanks, John. And you also see PMG, and Osborn is now part of PMG. And PMG is the public media group, and one of the things PMG now, among other things, is committed to building out single frequency networks all across the country in markets that are transitioning to ATSC 3.0. So I'm glad everybody's been talking about single frequency networks, but I'm going to go a little bit further into it and what we're doing. So as we talked about, single frequency networks improves receptions for consumers. And because we sort of take a cellular approach to the infrastructure by building smaller towers and building the towers where we need to fill in the coverage. And also, very importantly, keeping up the bit rate for the mobile, portable, and building penetration. But also talk about a little bit about LDM, was mentioned earlier, how you can get more capacity in the same 6 megahertz. And also, the important need to transition a market to ATSC 3.0, but keeping SFNs in mind before you do that. So we already talked about it, what an SFN is, where several transmitters simultaneously send the same signal over the same frequency without interference. And of course, OFDM and ATSC 3 allows you to do that. What's important, because it fills in the gaps, improves reception for mobile devices, and provides more comprehensive services to the community, and obviously, hopefully, for greater revenue. One of the things that we're doing, we're building them out, is what we believe is that SFN should be co-located. That means that all the stations in a particular market will be on the same SFN sites for a couple different reasons. One is reduce costs and improving service, and two is because we think the consumer electronic manufacturers be more advantageous for them to look at the technology to put it in mobile and portable devices with stations in the market having similar and comparative signals in the market. Some of the goals, like you said, improved over-the-air coverage for TV sets and handheld mobile devices. Provide consistent city-grade signal across the coverage area. So right now you've got your one tall stick, which you may get a city grade that goes out 10, 15, 20 miles. This gives you the city grade across the whole area, which Mark talked about a little bit about that too. It also improves the over-the-air service significantly, gives the MVPAs a run for their money. So, and then provides a data conduit for new revenue opportunities. So I'm going to talk about a little bit about the design criteria that we're looking at. So receive levels, rather high, 75 to 80 dBU. That's what we're starting out with. It may even go a little bit higher than that for building penetration. We're looking at the 25 megabit minimum bit rate for total rate in the core layer. So that's the minimum bit rate that we want to keep consistent. So when you look at more robust Mod-cods, you may go down in bit rate with a single tower. You might have to, for mobile, you might have to go to 10 or 15 megabits. This keeps the 25 megabit constant throughout your whole DMA. We're also looking at a 19.2 dB signal to noise for the study. We're validating other use cases based on client input, whether it be autonomous vehicles along highways, targeted advertising in the market, things like that. You also want to pick a guard interval based on the transmitter spacing. So you don't want to space the guard intervals too high, then you'll lose some data rates. So we have to look at that as well. And then, importantly, we're looking at using existing towers. We're doing some work, and I'm going to talk about that in the San Francisco area. It's almost impossible to build towers in San Francisco. So if we were to build new towers, it'd probably take, who knows, the next 5 to 10 years to build it out. So importantly, we're looking at using existing towers, if possible, for the faster implementation. Some of the modeling we're doing in San Francisco right now, we're doing engineering studies, and we've been doing this for a couple of years now, looking in San Francisco, and Madeline talked about some of the impossible terrain out there. We're looking at 3 host stations, 2 UHF, which is channel 36 KICU, channel 28, which is KCBW. We're also looking at a high V in San Francisco, which is CRON on channel 7. So here's some of the engineering that we've done so far. This is 10 meters, 30 feet. You saw the antenna on the roof, what the FCC uses now. So the left-hand site is channel 36, and that is just their one site right now for transmission. As we go over to the right, we go to a 7-site SFN, which we have planned out for, which you can see it dramatically increases the coverage over to San Francisco and practically all the way out past Sacramento. Madeline said that with one site you could get 40%. We're looking at, with 7 sites, 80 to 90%. So it dramatically improves the coverage. Look at this also at 1.5 meters for mobile and portable. You see the one site on the left, and then with the 7-site SFN, significant coverage increases. One thing that's pretty amazing too is I wanted to show you some population gains. What's very surprising is, I'll start off with Cron, which is a high V. Their population gain at 10 meters was over 2 million, and at 1.5 meters, over 2.3 million. So pretty significant with an SFN. For the UHF stations, significant increases as well. 1 million to 2 million population increases for them as well. It's pretty amazing. Another thing that was slightly mentioned before was LDMs, which is part of the 3.0 standard, 8327. And what it does is allow for additional modulated carriers at power levels other than the main to enhance and give you extra capacity. I was reading a couple papers, and somebody actually compared it to a double-decker bus, where you add another layer on top of the bus, and you get twice as many people in the same frame over the roadway. So LDM is sort of the same thing. You can get additional data capacity by doing that. So turning on the enhancement layer at recommended levels does really not have any material effect on the core layer reception. So you can see that the red level is the enhanced level, or the red line, the red signal is the enhanced level, which is 5 dB below the core. And the enhancement level, sorry, the enhancement layer can be used at different Mod-cods depending on the use cases, which if it's 5 dB lower, you have to make up some significant gains. So what we could do is a more robust Mod-cod to do that. Potential use cases: you can use broadband data across the DMA with multi-transmitter SFN design. You can get additional program streams. You can get program enhancement layers for 4K or HDR, although I was told out at the CES that a lot of the new TVs didn't have the LDM in it yet, but hopefully in the future they will. You can use it for emergency messages and warnings. And typically, which is kind of amazing, is the capacity will increase by 10 dB, 10 megabits over the core layer. So we talked about initially with 25 megabits. This would also give you another 10 megabits, so you get 35 megabits. So why this is important is when you start out with the host stations, most of your host stations will already have the main programming taking up all that, maybe 15, 20, or 25 megabits. So this gives you an extra 10 megabits, of data to have and do testing, extra projects and things like that. So you can also, use cases will define the Mod-cod. Again, in Mod-cod, similar to the core layer, Mod-cod will vary with applications. You can select a high robust Mod-cod where the bits need to go everywhere, reliability to low signal areas, and then a less robust Mod-cod when bits are not as critical in low signal applications. Here's the LDM. So the map on the left was channel 36. You saw that before. That was at 1.5 meters. The coverage in San Francisco, which had the SFN turned on with the 7 sites. On the right is the LDM layer, which gives you almost the identical coverage area. It's 5 dB down, but gives you the additional 10 megabits of data. So the coverage is almost identical. So I want to talk about a little bit what I said, planning for single frequency networks during the market transition. So we think it's important that when you pick your channel assignments, you pick them to support the SFN deployment, primarily for the interference, because the problem is the legacy ATSC1 interference. So you need to watch out for first adjacent channels with the ATSC1, because even if you're on a co-located tower, as you move further out from the tower in your DMA, that the interference increases. So you have to really take a look at that. And also planning for high V and UHF stations. So we're looking at planning and looking at high V as well for SFNs. We actually think it's more important for high V to have that extra signal level. So in summary, you create a uniform receivable maximum civil level for all stations through the DMA with SFNs. ULI for the highest possible data rates for mobile and portable reception. Obviously, we talked about that. They also can be used to replace translators in markets. So we have some groups, especially in public broadcasting, have a lot of translators and statewide networks who are looking at using SFNs to broadcast on the same frequency to save some bandwidth. So they also can use at various locations with different power levels to fill in reception areas. And down the road, you might look at on the highway putting a transmitter, maybe a couple of 100-watt transmitter on a light pole, putting them on the highways to fill in that kind of reception. And also, LDM can be used for additional multi-use data. And again, most importantly, SFNs will work best when they're planned for in the market transition to 3.0. And this is our team. If you have any other questions, I know Christina is here and she'll be around for questions. Stacy will be here later and we'll be around later for questioning as well. And thank you.
Jeff, great, thanks. And we have time for a number of questions. I know you had one. Was it for Jeff or? Okay. You know where the other microphone is? Okay.
Thank you. Hi, I'm Monty Taylor from Communications Daily. I know the FCC has an open proceeding right now where they're talking about adjusting the rules for how SFNs can be deployed, like interference rules. How important is that going the way you guys want for this? If the FCC doesn't change those rules, does your plans have to change?
Well, it's good to talk to the antenna manufacturers because their designs have to change because obviously you want to keep the interference out, from going out of the DMA. But I think it's important. I think that I'd like to see rule changes, especially say when you're doing mobile, that it would be great if you could go down the I-95 corridor and go from Washington to Baltimore to Philadelphia and New York and Boston or whatever and have a contiguous broadcast and pick up with that. So I think it's important that we look at some of the rules and changes, but the one that's in there now we think is very important for the interference levels.
Can you still deploy SFNs the way you seem to need to reach the mobile devices and such if the FCC doesn't make that rule change?
The way we're designing it now, we're keeping it within the contour of the largest signal in the market. So yes, we can.
Any more questions on RF design, antenna patterns? John's here. Yeah.
Yeah, thanks. I was wondering if you could talk a little bit about backhaul, if you will, how you're getting the signal to the various towers at the same time in order to facilitate this, and whether that's an infrastructure build-out challenge or if that's.
Obviously, it is a challenge. We're looking at fiber. We're looking at microwave and even over the air. You can do that as well. But we're also looking at data casting and data networks and doing that as well. And actually, Stacy is here and he's going to be talking a little bit more about that, about sending the data across and the schedulers and the mini schedulers to each of the sites and things like that. So that's something that's a big part of what we're doing as well.
You see this these frequency networks replicating existing LTE as far as you've experimented it more?
It can, it certainly can. And like you said, one thing is with the cellular approach, you can kind of build out as you need it and everything like that. So, obviously we don't have unlimited funds and there's got to be business plans and things on how we use that, but eventually, yes. So.
Any more questions on RF design, structure? No, Skip.
Just Skip Easy from NAB. Just to follow up on Monty's question, it is an important one, and it is an issue that we're tracking at NAB closely and hoping that it will go the way it will help. And just as a little forward promotion, shameless plug, there's a paper on this, and analyzing it from Merrill Weiss, who a lot of you know, at the NAB show in April. So we'll be tracking that, and you can find more out about it there. Thanks.
Madeline?
Yeah, just a quick comment for the folks in the room while there's no questions in a little bit of time. So Jeff referred to A327 in the slide deck, which is great because A327 is a recommended practice and gives an opportunity to talk a little bit about the difference between the recommended practices and the standards. So the standards are the nuts and bolts of this is how you shall do it if you're going to do it. The recommended practices talk about, okay, you want to fulfill this use case, this is the best way to set things up. And A327 is one of our most popular recommended practices that talks about for all the different use cases you might want, here are recommended mod-cods, here's ways that you might want to do it. So all of these documents are available at atsc.org for the low, low price of free. So check out the standards and the recommended practices in order to get your implementations on the road. Thanks.
We have a number of RF-related sponsors here. Anybody else from any other companies have any comments on what's been presented here and how you see transmission systems change or reach new consumers? We're ahead of schedule. We got about over about 7 or 8 minutes.
We'll be around later for questions if anybody comes up with anything.
I guess we can go to the next presentation a little bit early. Thank you very much.